Okay, so yeah, I would like to welcome everyone. Thank you for joining the SPACE4Cities Capacity Building webinar number 1. My name is Alex Gluhak. I work for Open in Azure Smart Cities, which is a partner in the SPACE4Cities project. We are an international city network working together on digitizing together using common standards and common approaches. This sort of webinar is one of 4 over the next couple of days, so it will be quite intense. It's basically really trying to reach out and explain a bit more about the emerging solutions around space technologies and space data and how they can help cities and regions. So I hope you'll find this topic exciting. Today's topic is infrastructure and ground monitoring. And the overall objective is really to allow other cities and communities to learn more about how such solutions could be used to help solve challenges on the ground. Also look at provide early access to some of the developing solution ideas before they become market reality. As you know, we've got 20 different now companies that we are working with and organizations. So we're excited to provide you with a preview of what's coming next in this technology landscape. And also it's an opportunity to ask directly questions to our experts, who we use, 5 of them you'll see in this call. And also it's at the same time as well a way for other citizen regions to think about potentially even becoming a replicator city. As you know, SPACE4Cities will later as well open up the pilots for other cities to join in as well. Just a few things about the project. So SPACE4Cities is a project that is funded by the European Space Program, and it's really it's called a pre-commercial procurement. Really, we are trying to procure innovations from the market that utilizes space data and space technologies to allow cities to better manage public areas, green spaces, mobility and transport infrastructure, and so on. And it's really to ensure that cities become more resilient, more sustainable overall. And our project consists of 5 what we call buyer cities. So these are sort of cities leading the procurement. They include obviously Helsinki, Amsterdam, Guimarães, the region of Attica, as well as Ghent. At the same time as well, we've got a few partners like us and Aerospace Valley to support with outreach and also ensure that the innovation is managed accordingly. And what you see here is we've had a big call launched early this year where we are looking for different solution providers. We had over 140 applicants, which was exciting. And in the end, 20 lucky, but also very brilliant suppliers got selected. And today you will basically hear of 5 of them. And later on in the afternoon, we'll have obviously another session and tomorrow as well. So you can really discover all 20 with whom we are now working with. The agenda for today is as follows. So we've obviously our talks, they're sort of strategically clustered here around infrastructure and ground monitoring. So you'll have 5 different presentations of 10 minutes each from each of our supplier partners. And then these presentations will be really one after the other. So we will not take a break for questions then, but there will be a panel conversation at the end. Then we've got half an hour then really to then discuss a bit more and also ask all your questions. And you're invited obviously to use the text box as well in the chat if you want to ask questions. Ari will keep an eye on it and pick it up for the later panel discussion. Or you can also raise your hand later and then ask a question to the audience. It's up to you. Then our speakers obviously is Reda, Candela, Joanna, Daniel, and we have Denise. Sorry, it's not Ricardo from Neptune. But yeah, Denise will introduce herself a bit more. And a few housekeeping rules just as well to ensure that the whole session runs smoothly. So we want to make sure that everyone who is not speaking to turn off the camera and keep their mics muted, obviously. And as we say, use the direct messaging for interactions. And later, obviously, we'll have the Q&As at the panel session. All right. Then just a final reminder, I mentioned there are other sessions as well. So 2 days, obviously, the infrastructure and ground monitoring in the mornings. Then we've got a webinar in the afternoon as well on green space management. And then tomorrow, there are a couple of more around climate risk in public spaces and mobility management and emissions. So yeah, hopefully, I don't know if you're registered for those, but there's still an opportunity. So if you're interested, please hop on. Okay, that's it. And I will now hand over to my first speaker, which is Reda. Okay.
Good morning. My name is Reda. I'm the co-founder of Survintel. I'm a geoscientist, educated in both geology and geophysics. Today, I will present Georisk Monitor, the service that Survintel and Gisaya are developing for European cities. I will start by telling you the story of a tunnel called Princess Margaret. It is not a fictional story, but the story of a real tunnel in the Netherlands, where thousands of vehicles drive through daily. It was built in the 70s, and over the years, traffic has increased dramatically. Cars and trucks are much heavier, but the tunnel was still functioning well until 2022. The tunnel had to be closed overnight because a section of the ramp had come up, making the tunnel unsafe for traffic. This issue came as a complete surprise because the tunnel had been inspected regularly and no damage was detected. After it was discovered, it was panic. Emergency measures were taken. 10,000 big sandbags were placed across the tunnel length, adding weight to stop the uplift. The repair of the tunnel is taking 3 years and is still going on. It was closed completely for several months. The diversion of traffic onto local roads caused other roads and bridges to deteriorate more quickly. They also led to dangerous situations with diverted trucks posing a danger to cyclists and pedestrians. The residents in the surrounding area suffered from noise and pollution. Drivers lost time due to delays and being stuck in traffic jams. The cost of repairing are 150 million euro, 6 times more than estimated initially. Why? The entire foundation of the tunnel must be replaced instead of just some parts. Costly emergency measures, unforeseen complications and delays due to water under pressure, extra costs of traffic diversion. The question you're asking yourself is, could these problems be spotted in time to act? The Dutch Ministry of Infrastructure consulted the market for a study based on satellite data, and this is what they acquired. A nice picture of vertical movement based on high-resolution satellite data. The white arrow points to a section of the tunnel brighter blue than the rest. It means an uplift of one tunnel section, and this was the spot where the damage was discovered initially. However, the Ministry of Infrastructure was not satisfied with this picture. First, it does not detect the other problems they observed. Second, this picture does not say anything about the underlying cause of the problem. So they came to us for a more refined picture. We performed our extensive analysis on the freely available Copernicus EGMS data, which others considered too low resolution for this type of analysis. And we obtained a higher resolution with the free GMS data, higher than the previous analysis did with the commercial RadarSat-2. Not only we identified exactly all the sections of the tunnel that were damaged, but also the cause of the damage. The region is affected by strong subsidence, but the tunnel is resisting subsidence and even recording uplift in some sections. The previous deformation was underestimated because it appears 1 order of magnitude lower than the region. The soil subsidence under the tunnel created cavities filled by water under pressure. Uplift is actually observed where anchors have failed. So could these problems be spotted in time to act? Of course. We have shown that this was already visible from the end of 2019, 3 years before this discovery of the first damage. Let's focus on the southern part of the tunnel. Ground motion is complex. Focusing on vertical movements is a dangerous simplification. This picture shows the stress we identified on some specific sections in the southern tunnel ramp. The other solution did not detect any anomaly on this part of the tunnel. We, on the other hand, did not only detect which sections of the tunnel were damaged, but also how the sections were tilting and sliding because the anchors were broken. Our analysis of deformation patterns are based on geological modeling and machine learning. We have more than 30 years of experience in modeling the underground. All these observations were confirmed 100% correct by the company who did the repair work. I will not bore you with our extensive analysis, but if you want to take informed decisions, you will need to identify all the details of the true deformation. The cherry on the cake, all that while using the freely available EGMS satellite data. Why does this concern you? Well, Princess Margaret Tunnel is representative of what is happening to a city's infrastructure. It forms an essential part of the functioning of city life. And if it breaks down, it is not only very costly, but also causing a lot of trouble. Why could this happen in your city? We have seen that the intensity of the deformation could easily be underestimated. The combination of aging infrastructure and increased traffic have an impact on structural integrity. But cities also suffer from extreme weather conditions. Sometimes the weather is very warm and extremely dry. Other times there are storms and heavy rains. Structural integrity is dramatically affected by these variations. We want to help cities to avoid nasty surprises like the breakdown of the Princess Margaret Tunnel. Our analysis of deformation is physics-based and therefore apply to any kind of infrastructure: roads, bridges, dams, railways, and buildings. That's why we are designing a service called Georisk Monitor. We are combining the advanced geoscientific algorithms from Survintel with GISAIA's expertise in developing robust geoanalytics data platforms to scale up our services and deliver actionable insights to any city in Europe. With Georisk Monitor, civil engineers understand what is going on and what needs to be repaired. In this case, they would have known exactly which section of the tunnel were moving, how they were moving, why they were moving, and what sort of damage could be expected. With Georisk Monitor, cities can identify and understand the issues before they become huge problems. Cities will have time to implement an adequate remediation plan. In this case, they would have known 3 years earlier about the problems and would have had time to take appropriate action. With Georisk Monitor, the city will save considerable cost by identifying the issues, avoiding approximate emergency repairs. Planning repairs in advance is always more efficient and cheaper than doing them under high pressure. In this case, it is estimated that the remediation plan would have reduced the cost of repair by 90%. And on top of that, the indirect costs such as traffic jams, detours, unsafe situations would have been avoided. So, if you are as excited as we are to build this service together, then come and talk to us. Thank you.
Thank you so much. Yeah, you've kept very well in time. Perfect. So now I am looking for the second speaker, Candela. If you could sort of also try to share the screen, and then the floor would be yours.
Perfect. So thank you very much. And hello, everyone. My name is Candela Sancho. I'm the CEO of Detektia. And today I want to talk about how we can unlock intelligence in urban deformation processes by integrating large language models and INSAR for scalable city risk management. So, as previous presenter has shown us, INSAR allows to monitor how cities evolve over time with millimeter precision. It generates a deformation time series for the buildings and infrastructures. So, can you see my camera, or I am?
No, we can't see you. Actually, I wanted to say,
sorry.
maybe turn on your camera. Okay, thank you.
Yeah.
Perfect.
Sorry. So I was just saying, like, INSAR generates a deformation time series for the buildings and infrastructures of the entire city, creating an incredible, dense, continuous data set that spans the entire urban fabric. But with this huge volume of info comes a challenge. Across a single city, and you can see here a picture of Amsterdam, INSAR can produce hundreds of thousands of long, complex time series. And while this data is rich with potential, it's overwhelming in practice. City managers usually do not want to learn how to use advanced time series analysis tools. They just want to answer questions. When did something unusual happen? Where is the problem? How much did it change? And it is getting worse. So, what if getting those answers was as simple as asking questions? So, what if we could explore city-scale deformation patterns just by using natural language? No need to code, no need to model, just ask and let the system do the work. So Detektia already provides advanced tools to analyze large volumes of deformation data, delivered seamlessly through our API. So this is the core idea behind our innovation in the SPACE4Cities project, combining the power of advanced Detektia API with the simplicity and accessibility of large language models to transform overwhelming geospatial data into intuitive, actionable insight for every city. So this slide is a summary of Detektia's current technology. So the main capabilities include access to deformation time series, historical, current, and to query deformation along the client's defined axis, vertical, horizontal, slope directed. So the client can choose. And we also calculate automated deformation metrics. So we compute stability indicators such as accumulated deformation, differential settlement, deformation gradient. We aggregate data over structures. We receive alerts on trend changes, sudden accelerations, anomalous behavior. So anomalies are detected through time series forecasting and deviation analysis. We also have predictive modeling. We access forecasts of future deformation and its monitor location. And all this model can incorporate external variables such as precipitation, temperature, or aquifer levels. So we also apply unsupervised machine learning models to identify spatial patterns of deformation and classify areas with similar temporal behavior for faster interpretation. We have a RESTful API with standardized GeoJSON responses for integration with a geographic information system, building information model, digital twin platforms. So we can filter, we query our API and we filter results by structure, type, deformation thresholds, anomaly status, proximity to urban projects. And all these functionalities can be seamlessly integrated into any software environment, including, as I mentioned, GIS platform, digital twin, geotechnical analysis tools, through the direct connection with the API. So this slide shows the new layer we are developing as part of the SPACE4Cities project, an artificial intelligence agent powered by LLMs that interact directly with Detektia's API to answer user questions without requiring any prior knowledge of INSAR, time series analysis, or the API itself. So this layer will let user query Detektia's API in natural language. So to enable this interaction, we are using technologies such as function calling and model context protocol servers to connect LLM-based agents with Detektia's API. And we will demonstrate the power of our solution through a few practical examples. So this is the case of a construction of a watering tunnel in Genova. And this is the traditional INSAR analysis. So after the construction of the tunnel, we can see some deformations. And how can we analyze these deformations? So we really need to know some insight about how INSAR works and how to extract the informations. And we can compare over this profile line how were the velocities before the construction in red colors and after the construction in blue colors. But how can I say which is the affected area? So this is the moment when we can ask. So can you delimit the areas affected by the works in terms of homogeneous behavior? Or can you show me the deformation series of the area with the greatest deformation? So in this case, through LLMs, we will connect with the API and use the clustering tool, and we will be able to answer the question to the manager. Yes, you can see all the time series in the purple colors, and then you can see you can delimit the affected area with the purple points within the map. And let's see some other, and for instance, maybe the manager wants to ask, so can you show me which are the buildings more affected by this work? So the LLMs will call the AP and the structural health indices, and we can easily identify the most affected buildings in this area and also classify them by the degree of affection. And we also do forecasts, so we can say at some point in time, just 1 month after the construction of the project, can you show me the points with anomalies? So we compare the forecast time series with the current measurement. So we can see, yes, you can see with these triangles the locations where you have anomalies. And 3 months later, any updates? With the anomalies? Yes, you can see the new locations of the anomaly points. And we can repeat this question in natural language through time until the project is finished. And this is another example. So thanks to this SPACE4Cities project, the manager can ask to the system, okay, which areas of this part of the city has been accelerated? Where are new warnings? How big are them? And this is an example of a specific construction project, a metro construction project in Madrid, a moment in time. And we can say, which are the areas that are having largest deformation? And we can also ask, can you tell me which is the building with most probabilities of cracks and instability issues? And we can also answer this question. And these are just, as I mentioned, examples of concrete deformation that are happening in a city. But in a city, multiple deformation processes occur simultaneously, driven by different causes and affected different areas. So having direct access to information and analysis algorithms by simply asking the right questions will help to extract the full value from Sentinel-1 data and INSAR technology. So thank you very much. This was our presentation.
Thank you, Carolina. Seems that everyone is keeping well on time, so we might be actually faster through. But good, no, amazing. So our next speaker is Joanna.
Yes. Oh, can you see my screen now?
Yes, it's not in full presentation.
Yes, I will put it in full. Here we go.
No, unfortunately, it's now the mode for you. So the preview mode. You might want to have just the presentation mode, not the one with the comments. Yeah. Now it's good. Perfect.
Okay, great. Well, good morning, everyone. My name is Joanna Einhorn, and I work as an application engineer for Sensar. I have a background in aerospace engineering and remote sensing, and I would like to tell you more about the City Elevation Monitor, which is our solution for the SPACE4Cities project. We are also addressing, same as my previous speakers, the urban planning and management challenge, actually, and we all know about the aging infrastructure, outdated or incomplete information about public spaces, but also the increasing need for sustainable practices and budget constraints, of course, and the high complexity in data fusion. And the City Elevation Monitor is a solution that provides insights into the visible and invisible changes in elevation. And it actually consists of three different components, which is the city scan, the city detect, and the height mapper. The city scan will give millimeter deformations from space, actually. The city detect can highlight mutations and inundations in a city. And the height mapper will provide an up-to-date space-based elevation map of an entire city. These components are all linked to each other, because if we, of course, have a new detection of, for instance, infrastructure or a building site, this might bring the urge to actually check the surrounding areas for sudden deformation changes, or even very small deformation changes during the building of the project. And of course, new infrastructure brings the need for a new elevation map. The city elevation monitor uses different source data, actually, and my previous speakers have already mentioned a couple of INSAR and EGMS as well, which is the European Ground Motion Service that provides Sentinel-1 SAR INSAR data. SAR imagery will be used by the city elevation monitor, as well as also geospatial data sets, and they can be open source, of course, but also provided by the cities. The data processing part for the city elevation monitor consists also of multiple parts. Of course, we are making use of different algorithms. Firstly, an INSAR algorithm, which is in-house developed. So we are not dependent on any external algorithms or external tools. The mutation and outlier detection algorithm, of course, for the city detect component of the solution. And yeah, last but not least, the SAR to height technology that is also part of the data processing and will be developed as well still in this project. The CEM, or the city elevation monitor, is actually a tiered service. So what we will provide is different levels containing a light, a basic, and an advanced level of the city elevation monitor. They all come with different level of details, which also means they come with a different level of costs, which actually makes it possible for all kinds of cities to make use of the city elevation monitor. So cities of all sizes will be able to use any of the levels, and also can fit a level to their own needs. I would like to mention the monitoring pyramid, actually, because we believe that the city elevation monitor will be part of the monitoring pyramid as we know it, basically using local measurement tools and local inspections. But we would like to add a new layer, the detection layer, with the city elevation monitor as well, that basically provides the data-driven and risk-based management to the asset management way. Our end users are the municipal professionals, such as asset managers, technical managers, but also policymakers and GIS engineers, to be able to work with the city elevation monitor and the output data that it provides. Integrating it into the monitoring pyramid adds this detection layer, so it's a more effective and efficient way of allocating the resources and the planning as well. And of course, it brings advantages as well in enhanced safety, because early hazards hazards can be detected early in that sense, and it improves, of course, the infrastructure management part as a whole, as we know that we can basically get an up-to-date elevation model from the city elevation monitor, and such that planners and engineers can actually make more informed decisions. The cost part, of course, is one to highlight, because when something is detected early on, as also Rada mentioned earlier, it can help to actually prevent costly repairs. There's an aspect of environmental protection as well with the city detect, since we can detect then environmental changes as well, and take actions to protect natural resources as well. And it increases transparencies as well. For instance, citizens get a more accurate view and a more transparent view of how the city and the public space is managed. Last but not least, I would like to highlight some innovation parts. The city scan will be basically transforming INSAR point clouds into level 3 products. You can see an image, or yeah, like an image of the way on the right. We will go from the chaotic complexity of INSAR point clouds that are very difficult to interpret to an object-based informed way of deformation time series. As I mentioned, the different levels of the elevation monitor, of course, provide different levels of details. So it can be object-based, but it can also be neighborhood-based, also dependent on the need of the city. City Detect, will use advanced time series analysis instead of an image-to-image analysis of that commonly used algorithms or detection algorithms are using. And this gives an advantage of distinguishing actually mutations from outliers and providing some context to the actual type of change that we detect. It will be AI-based, and there will be an AI-based part in cleaning up the SAR image actually beforehand to denoise it to basically enhance the detections. And last but not least, the height mapper will of course make use of the SAR to height technology, which is as well AI-based. And we would like to push this technology to become an automated processing chain for an up-to-date elevation model, because currently the state-of-the-art algorithms are working with high-resolution SAR images and also only with one type of satellite. And we would like to make it applicable for different types of satellites and also potentially lower resolution satellite data, which then can be integrated in the city elevation monitor. Yes, I really hope I caught a bit of your interest, and if you have any questions, feel free to get in touch. Thank you very much.
Okay, excellent. Thank you, Joanna. So again, very on-time presentation. So this means a little bit more time later for conversations and discussions. So great. Good. Then next on my list was, I think, Daniel. And I think you guys are going to be like a double act with Yanis. Is this correct? Or
Yes.
Yeah, perfect. So I can see the presentation, and the floor is yours. Okay.
So allow us to do a little tap dancing together with Yanis. Hi, my name is Dan Katz, and I am one of the co-founders and president of eOnsight. And eOnsight is happy to present to you today the CHERISH program. eOnsight is a company dedicated to developing data analytics and Earth observation-based solutions to monitor infrastructures. Our team is composed of many professionals of the data analytics and IT and Earth observation business. Next, please. So why do the cities need CHERISH? So CHERISH, as you saw, means the cultural heritage in SAR, which is a technique based surveillance for hazards. So we aim at helping you, the cities, protect your cultural heritage all around Europe, starting with the 4 cities that we are involved in the first phase of this project. So the cultural heritage is critical for the economy of many European communities. Think of the visitors, the tourists visiting the cathedral, the fortifications, the historic areas that we all have in our European cities, and which are exactly what makes Europe so definedly different from the many other places in the world. But those treasures that we have, those cultural heritage, usually lack at the municipal level of a clear, continuous structural monitoring. And this is what we want to proceed with using space data. Of course, there are some sensitive areas where you have like ground sensors and things like that, but there's limited protection and monitoring over larger areas. And when damage occurs, of course, it's a catastrophe. So this is what we want to do. We want to create a solution that is non-intrusive, scalable, cost-efficient, to create alerts, and help the municipalities and the cultural heritage protection agencies better manage their cultural heritage sites. Next, please.
I'll take over on the technical part. So CHERISH uses Sentinel-1 SAR data from the Copernicus program to detect ground deformations at the millimeter level. We apply the so-called technique of persistent scatterer interferometry, or PSI, to monitor these small yet possibly dangerous trends like subsidence, uplift, or slope instability. And this is basically distributed over the whole European continent, so we can focus on any area of interest, as is shown here on the right on the example of the Acropolis in Athens, where we see that we have many measuring points available from the Copernicus constellation, the Sentinel constellation. And each point represents a couple of time series showcasing the movement of that point throughout the years, which, as you can see, can be, in this case, in the order of magnitude of about 12 millimeters per year, which can be quite important and impacting for the structural health of an infrastructure, especially if it's a millennia-old structure like the Acropolis. And within this project, we also plan to develop a dedicated AM module that translates this raw data, the time series, into actionable asset-level risk insights for the use by the cities and the managers of these cultural heritage sites, and of course in the utter scope to prevent the exorbitant costs related to potential damage of these precious assets that define our European culture, as Daniel mentioned. So in terms of integration, what we plan to do is to have two components. The one is a ready-to-use, user-friendly front-end web application, and the other is APIs for a more customized and tailored interaction with our service via the more elaborate, possibly available services, geospatial information services are already deployed in your city, if this is the case. Why space data is essential here? Because Sentinel-1 data in this case is available already since 2015. So we can really establish a long-term trend analysis with confidence and reach reliable conclusions. There is no physical installation, no on-site action to pay for or to manage from your side. And of course, this comes also with a huge scalability potential, because we can literally monitor dozens or even hundreds of cultural assets in the same time across Europe, since this data is available across the European continent. And in phase 2, we plan to extend this service into with real-time or near real-time capability by directly processing the raw Sentinel-1 imagery.
So for whom is CHERISH designed and developed now? First of all, for the municipal infrastructure departments. Sometimes there are archaeological or cultural heritage protection, depending on how you call them. There may be internal departments of the municipality, or there may be also sometimes specific national agencies. This service will also be of help for the urban planning teams to better have a view of what's going on around the cultural heritage sites. Of course, it impacts and it has a connection with the civil protection authorities. Again, they may be inside or the municipality itself, or as separate agencies, depending on the way the municipalities are organized in the country. And of course, depending on the typical hierarchy and the weights and the ownership of the sites. Some sites may belong to the cultural ministries, or sometimes religious authorities that may have a different legal entity in a country. So the key benefits are that we will detect the risk earlier than currently. So we reduce, of course, the emergency maintenance, and we help support the planning and conservation of the building to preserve the cultural assets that are so critical for our European communities. Next. Please, the service developed for SPACE4Cities, the S4C, shall contain, of course, as many of our other colleagues explained, deformation maps, use of AI, artificial intelligence models, the key being able to use explainable AI models, not just AI models. So in order to exploit and to detect abnormal movements of the ground around the so critical cultural heritage sites, and of course this has to be integrated into the municipalities' tools which exist when they exist, and when they don't, then we have, of course, to deliver the full service so that the users can or the operators can arrive in the morning and have a global view of what's going on in the city portfolio of assets of cultural heritage assets. Next, please. So what sets us apart here is that we already work for another topic with municipalities in France. We work with the municipality of Meudon, which is outside of Paris, just outside of Paris, and and also the collectivity of several municipalities outside of, including Meudon outside of Paris, which is called Grand Paris Seine Ouest, and we tailor the solution for them, which is a product to follow the bridges. So we believe that we have the knowledge of how to integrate into a municipality system, how to deliver for the operators of the municipality what it is required to follow and monitor its assets, and we believe we can extend that to cover and monitor cultural heritage with all the specificities that it requires in terms of structure. And of course, with this experience, we believe we can bring to the monitoring of the cultural heritage of your respective municipalities. And voila.
Okay. So thank you, both Dan and Yanis, for your also good presentations. Obviously, it's nice to see both technical aspects and business aspects covered well. Yeah, that brings us to our final presenter of the first part of the session, which is Denise. So please, Denise, the floor is yours as well if you want to share your screen. And yes.
Okay. Good morning, everyone. I'm Denise.
It is not full screen yet.
Yeah.
So just so that you know. So,
okay. Yeah.
No
Good morning, everyone. I'm Denise, and I'm the program manager of Urban Lens, our project. Today, I'm going to introduce our project that is a cutting-edge solution developed under the SPACE4Cities initiative. Our focus is on smart monitoring of urban water infrastructure, and the objective of the project is to tackle critical urban challenges using space-based technologies with the goal of creating more resilient and sustainable cities. The problem, urban areas today face two major challenges that are climate resilience and infrastructure management. One of the most pressing issues in this context is the management of underground water systems, which are often affected by invisible leaks. In fact, for example, in Europe, water leaks are between 20 and 30% of existing water. These leaks not only led to a significant waste of resources and increased energy consumption, with a related rise in CO emissions, but they also pose serious risks such as ground instability and road collapses. Traditional methods to detect such leaks are often reactive, fragmented, and costly. They usually come into play when only when visible damage has already occurred, and Here, Urban Lens transforms this reactive approach into a preventive one. In fact, Urban Lens offers continuous and non-invasive monitoring of underground conditions. By identifying moisture anomalies and soil deformation early, cities can act before a small leak becomes a major failure. Our solution, our Urban Lens, combines two advanced space technologies to create a powerful monitoring tool. In fact, the first is GNSS reflectometry that uses signals from GNSS system with a special focus in Galileo system, which allows us to detect changes in underground soil moistures, even from moving platforms. And the second monitoring tool is SAR satellite imagery provided by Copernicus Sentinel-1, which tracks subtle ground movements and validates moisture anomalies. The multi-source data is processed and visualized through AI-powered GIS dashboards, which deliver near real-time georeferenced alerts to infrastructure managers. The result is a comprehensive, layered view of what's happening below the surface, something that was previously invisible and unmeasurable at this scale. Space data is essential for our solution and is very important to its success. In fact, GNSS gives us the ability to detect underground water anomalies dynamically, while SAR imagery provides precise measurements of land deformation. Together, these datasets enable scalable, continuous, and highly accurate monitoring of underground infrastructures. Without satellite data, such insights would require costly, invasive, and localized interventions. Urban Lens brings a much broader, smarter perspective and one that supports citywide decision-making. Urban Lens is designed to support multiple stakeholders who play key roles in urban infrastructures. First, we serve municipal utilities and infrastructure managers, providing them with data to support smarter maintenance, planning, and investment decisions. In second, we have field technicians because they benefit from targeted, geolocated alerts that guide their on-site inspections and repairs. Another end user are urban planners and sustainability officers because they use our insights to inform climate adaptation strategies and urban development plans. And finally, policymakers and public administrators gain access to validate environmental data, which helps shape long-term infrastructure policies. In short, we can say that Urban Lens helps cities move from a reactive model of crisis response to a predictive model of smart management, making urban systems more efficient and climate resilient. What sets Urban Lens apart is the combination of advanced technologies and real-world validation. In fact, our SAR processing chain has been tested and validated in real leak scenarios and is now patented in 4 countries. We also use an emerging GNSS system, which is currently patent pending and allows soil moisture detection from mobile platforms. But the true innovation lies in how we integrate all this data from SAR, GNSS, multispectral imaging, and GIS into a single decision support system. We bring together a multi-faced team with expertise in Earth observation, AI, urban infrastructures, and environmental engineering. Urban Lens is also perfectly aligned with the European Union's missions on digital transition and smart water management, making it a valuable tool in today's policies and funding landscape. Urban Lens is built to scale. The system is fully compliant with European standards, ensuring that data, privacy, and security are respected. It can be deployed in both small towns and large metropolitan areas. And during pilot testing, we expect to see a dramatic improvement in performance, such as leak detection times reduced from weeks to hours, up to 30% savings of non-revenue water, and a significant reduction in emergency repair interventions. That means a better service for citizens, lower operating costs for utilities, and reduced environmental impact that is a win for everyone involved. Urban Lens is not simply is more than just a technical upgrade. It represents a new paradigm for managing underground infrastructures. By combining GNSS-R and Copernicus satellite data in a modular and AI-driven platform, we offer cities a truly modern, evidence-based tool for climate resilience and digital transition. This approach aligns directly with the goals of SPACE4Cities, showcasing how space technologies can create tangible and local benefits for citizens. We believe also that Urban Lens is a powerful example of how innovation, data, and collaboration can reshape the way we manage the vital system that keep our city running. And thank you.
Brilliant. Thank you, Denise. Well, again, another very timely presentation. So yeah, thanks so much for this. And that sort of completes our first part now of the webinar. And yes, I would like now also to ask all the other presenters to come back live, put on your camera, and we will now have an opportunity, obviously, to have a panel conversation. And obviously, also you will also be able to receive questions from the audience, which we can then address as well as part of this. Okay, so yes, brilliant. Okay, I can see everyone there. Amazing. Good. Reda, are you still around? I think Reda is still missing, at least on the camera. Okay. Well, maybe he'll join in a minute. Good.
Yeah, sorry. I'm here.
Yeah. Yeah, perfect. Yeah. So yeah, this is now like the slot, the second slot, which is basically focused on the panel conversation. We are running 1 minute early. Okay. So yes, great. So obviously, I could see. I think we were pretty good clustering those presentations in the end. I think there was quite a bit of similarities in let's say at least the sort of techniques that many of you guys are using in terms of your solutions, but obviously maybe application cases were slightly different, which makes it also more interesting. I had obviously a few questions, and I may ask maybe each of you a few before we then open up the floor to the audience, if it's okay with you. One of them maybe was that what is actually your expected business model, right? So when you are now providing the service to you, maybe you can have a quick one by one, right? How do you expect your services to be provided to the customers and clients and cities? Is it a subscription model, for instance? Is it a consulting model? Is it like a project-based model? So how do you operate? And maybe Reda, we can start with you and then maybe move to the others as well. Sure.
What we several times discussed with a couple of our customers is that it could be a combination of both a subscription service and consulting service, because there are always different layers of difficulty or expertise in the understanding. It's like everything. First, you need to sort out what's happening, and that is an easy subscription service. You classify zones, prioritize the events, the actions, and then you go into a more detailed analysis of either an extra level of subscription or directly consulting mode for very specific details and very complex message. So a hybrid, I would say.
Okay, hybrid. Yeah, it's good. I mean, obviously, does it mean as well that you will tell them how to fix it, or is it more like working together with a, let's say, structural engineering company that then would be able to deliver a solution? Let's say in the case of your tunnel, right? So
yes,
yeah.
By experience, I would say both. Because satellite data is quite new, it's complex, and it has a lot of uncertainties. We don't see very much everywhere people talking about false positives or errors. So there is a part of education. So a discussion really with the customers is more the way to go, actually. So deliver the service, give the advice, but also listen to the customers and train and educate into how to do it also themselves, and probably develop the tools of the future with them together.
Thank you. Candela, how do you guys operate? I mean, obviously, I know you seem to have already an existing system that you're using now. Obviously, you're developing the LLM on top as maybe a sort of more service that makes it maybe easier, I guess, to use your tools. But yeah, explain us a little bit more what you think.
Yeah, for us it's complicated. I don't know if it's the same in other European cities, but at least in Spain, trying to get a contract with a public administration is a bit of a pain. I mean, and especially if we are talking about young companies, startups can take forever and take all your energy. So it's a situation that we haven't fixed, let's say. So it's true that we are working very nicely with all these companies that work for the city halls. And then, everything is easier when you talk to a private company. So in our case, we realize, I mean, we are not civil engineers, we are not urban managers. So we are experts in satellite data and machine learning, AI. So this is what we do. We provide all the tools to analyze the insert data, correlations with external variables, but it's up to them, which is how do they want to integrate the data and what they want to do with the data. So let's say we are a SaaS. We have annual licenses, but yeah, mostly talking about the companies that works for the city halls. So I don't have an answer yet for the public administration.
No, that's fine. It's good. You're part of the supply chain basically, right? But yeah. Obviously, yeah, perfect. And you're providing then this consulting services, I guess, or to basically other organizations or companies that closely work with municipalities. But Joanna, I mean, you actually mentioned the business model first, actually, because you said it's a tiered business model, so like 3 tiers and stuff like this. Elaborate a little bit more, and yeah, how are you sort of working, or you considering your business model to be for this service?
Yes, yeah, thank you. Yeah, as you mentioned already, like the idea is to have a tiered model for the solution. Starting with a light level, which basically is a demonstration product. So yeah, basically customers still have the time and the action to figure out, is this product really for me? Can I do something with it? How am I going to use it? And then, yeah, the basic and advanced levels will be more of a subscription model, since we're also talking about, of course, providing up-to-date information on the elevation of each city. And there, a subscription is, of course, the most ideal part.
So like an annual fee to your service or something like this?
Yeah, in a way. And it can be anything depending on the need, I would say. And this is the early stage to figure this out, of course, as well.
Okay, that's good. Yeah. Good. And Dan, what's the situation with you guys? You said you're already working with some municipalities around tunnels. But yeah, what's obviously you can monitor now all cultural heritage assets across Europe. So how do you consider sort of like your business model?
The model, we are not a service company. We are a software company. So we design a tool and we sell the tool to the operators inside the municipalities or inside the national agency or regional agencies that follow the assets, the infrastructures. And these people exist, and we are in contact with them. Everything is mostly public procurement, unless there's a delegation to another company. To a private company, but we handle public procurement. The French being super into bureaucracy and stuff. So we believe that our first fireproofing of knowing how to deal with the French bureaucracy, we are good enough to go with the rest of Europe. This is something where France is so infamous for, so that we believe that if we survive the French bureaucracy, we can do public procurement, and we know how to sell that, to install it also in the systems of the persons. And it's not just using space data, because we know that the users have daily other issues to tackle. And for instance, when we talk about cultural heritage, the people are the people who take care of those churches. For instance, if you take a church, people are also very much concerned by the inventory inside the church. Sometimes you have like statues, pictures, stuff that are like from the Middle Ages, and they need also to have a listing of that. So they needed to have a repertory of everything in the catalog. So we create a product which would not just be about telling them when the ground is moving, but also having a tool for the daily management of their cultural heritage assets.
Brilliant. Maybe there are a few tips you can give Candela about public procurement, and it could work in Spain. Let's see. Perfect. And then, Denise, maybe what is sort of your sort of business model? How do you think of commercializing your solution? It seems it's quite focused on water infrastructure, right? Or like pipes and things like that, right? There might be also lots of private companies that operate this infrastructure, right? So how do you?
Our business model is structured around a data as a service approach. In fact, we offer our portable GNSS system under a fixed fee operating this model, which normally includes unlimited kilometers of network inspections, centralized data processing, and access to our WebGIS platform. The client typically are public water utilities, and they remain fully autonomous in terms of logistics. In fact, they can transport and operate the device using their own or third-party vehicles. The system is non-invasive, plug and play, and designed to be easy to use even by non-specialists. This model provides non-per-use fees and ensures fast scalability across wide networks, while we handle data processing, updates, and support. So yeah, this is our business model.
Thank you. Good. I just have a few more, maybe more technical questions before we then take the questions from the audience. So one of them, obviously, I could see that there's quite a bit of commonality that you have in terms of, like, let's say geological deformation and maybe height analysis that your solutions do. Specifically, I guess the first four solutions sit in a similar bucket, but maybe with a slightly different angle. So I guess Candela has something like an LLM model that could potentially also be useful for any of your other services, for instance, right? Is this something that you considered as well, the use of LLM, similar to what Candela had, as a more natural way of asking and posing questions about data that your system analyzes or not? Maybe this is more question for Reda, Joanna, Dan, and the others.
Well, so far we have focused on the science. We have focused on getting a reliable signal to interpret, because it's quite nice to have beautiful pictures of everything, but if it's not correct, that would be an issue. Of course, another layer for when the platform is developed, the platform that should be used for the subscription for expert and non-expert, and an extra tool could be an AI agent for asking questions or simplifying the access to the data. Of course, that is always possible. For us, it's not just a priority at the moment. First, we did the science. Now we work together with Gisaya to have this platform to do the subscription, access to the data, and then maybe in the future we'll add some AI agents. Yeah, it is possible.
Good. How about you, Joanna or Daniel? Have you considered the use?
Yes, actually, it's coincidence, I guess, but we are busy internally in the company as well to look more into it and to maybe develop it as well for also more of a final product. This is really the early stage of like we're trying now more to combine different components, like with the detection algorithm and the start to height technology to provide an overall package. And then, of course, I also mentioned like it should be easy interpretable. And then there, the LLMs definitely come into play. And it could be interesting for, the final stages of a web-based solution as well.
Yeah, maybe something to consider, maybe for sub-licensing. You know. Good. Then, and you, Dan, and stuff, and Yanis, have you thought about this? Or?
Yeah, Yanis is going to help me because he's the data scientist and he loves science. The thing of being an idiot like me is I don't care about the technology. I care about what the users need. And we've had a lot of work session with the actual operators at the municipality levels. And we know that in the morning they don't come and say, oh, am I going to ask the AI to do something? No. They know they have to do something. They have to send a team to check on the bridge, for instance, or to check what's going on around a monument in the city or what. And this is what they do. And their job, we have to follow them in the way they operate every morning when they go to work. I don't care if it's LLM, SHMLLM, or AI or whatever you call them. We do use space data because it's powerful, and maybe that's also why we all kind of use the same technologies in space data because they are so powerful. But we want to bring a service to the client. We want to bring a tool that is useful and that they use every day. So we insist very much on the UX UI and making it super simple for the operator. Every morning you come in the office, you switch on your computer. What do you do? What is the first thing you do? And people don't check data. Either they have a red alert or they don't have a red alert. But the system that you deliver, the tool should go their way, not the way we, technicians, technologists think. So that's where we insist. But
if I may add, people are way too occupied with their daily routine. So as Daniel says, what people will do will check their emails, and basically our focus is on providing really a reliable alerting service. And the platform is to check a bit the details, but I'm honestly from a user perspective, I don't think any of the city managers will invest their time in playing around with a LLM for this professional use. At least this is not a viable regular activity for them, I believe.
Yeah, I guess things are changing as well, and actually I started using LLM a lot myself these days for obviously automating some of my mundane tasks that I have. So just in defense of Candela, but I understand again, alerts are definitely something that's quite valuable, and if they are right. But the thing is, and maybe just drive on this point. What if you raise an alert too late? Or you raise false alerts? How do you handle, or how does your customers then? So do you have any liabilities then? Let's say if a cultural heritage site, maybe you don't detect it, and then next day something happens. Will the customers come back and sue you and say, look, you haven't warned me early enough. I could have fixed, but now the part of the statue fall down or the wall fall down, and so how do you handle this sort of liability issue and alerts? Dan, maybe.
Yeah, the point is very interesting. It's true for all data-based system. But take the first database system that you can use is a thermometer. So you take your you take your temperature in the morning and you're 37, but I'd say it's okay. but then you're 38 and it doesn't tell you that you have, one disease or the other, or it's 35 and it doesn't tell you. We provide a tool. The tool measures stuff, brings them back to you in a dashboard, tells you what he suggests to do based on the history of knowing that at 39 degrees you're sick, but at 38 something, it may be just, like a small thing in the morning. And so effectively, we bring a tool, we bring the data as they are. And in terms of liability, our contracts, first of all, we will never evacuate the city just because there's something moving. There are other agencies that will do that. We will not ask Athens to evacuate the Acropolis in the middle of August just because we suspect something unusual to happen. So it's I mean, these issues are, and by the way, having a tool that tells you what, and having zero today, what's your liability? Because today you could have known, and you don't even have the tools. Tomorrow you have the tools and you could know, but you won't necessarily. For the bridges, for instance, we never think of having to close a bridge. We just say there's an anomaly, send someone. The movements, the ground movements are follow a trend which is not normal. So this is what we say, and this is totally true at each step, unless the data are fake, and which is then not our case. Knowing that we take pure data from European Union, so effectively we just tell the people to send the operators to send the team on site. So that's the picture of that Reda was showing, that you send someone and
understood. Yeah, makes sense. Perfect. So they still have to go to the doctor to figure out what's wrong with them, right? So
exactly.
Yeah, good.
Just like your AI is telling you that you should seek professional advice,
Yeah, but I can see that Reda is going slightly further, right? Reda, you are actually also trying to act as a bit of a consultant and maybe as a doctor or a medic, right? To a certain extent, because you are following up. You're just not saying there's something wrong, but you're also sort of trying to go a bit deeper, right?
Yes, you see, I mean, we can do whatever to have nice warnings and values. At the end, an operator has to take a decision, which is based on other parameters. For example, how much is it going to cost to evacuate a city, or to do an inspection? So even though the alarm is good, the decision might not be connected to the message. So what we try to do is to reduce the uncertainty, is to give more information, more attributes that makes more sense for someone to take the right decision. So that this is less painful to say, well, I'll have to intervene even though it's going to cost me more money, because on the long run, I reduce my risk and I will be safer. And the only way we could do that is to be more accurate, to be more precise in the detection, but also have multiple attributes converging to the same solution.
Excellent, thank you. Good. I think I've asked many questions.
Just one more comment on what Reda just said, is that everything we all do is decision support system. So we support the decision of a human. And Candela use of LLM is for to interrogate the system, not to have the answer. So effectively we all do decision support system, so we don't have that type of liability that you shown that you expressed, because we are beyond that. We are the tools that help humans make a decision.
Yeah, and it was mentioned by a previous presenter, I don't remember who, like, analysis of Sensar is not trivial, it's complex, it has limitations, and someone says, you have to train the client. So if you happen to be working with a civil engineering company, your technical one, they are open to learn because they are within this technical world. But sometimes you are working with a department, if the person either doesn't have time or interest or is beyond his scope of work. And sometimes this person doesn't want to learn about it. What happened? Misunderstood of the capabilities of the technology, of the applications. So, it's complex, so we need to be careful to produce an output that can be understood and is understood independent of who is the final user, that he must be an expert or he might not. So I think that is the question, to get the fully potential of the technology.
Brilliant, thank you. Okay, I want now to take this moment as well now to look at what kind of questions we have from the audience as well. So I've seen there are a few questions that have been posted into the chat window. Ari, do you want to sort of walk us through?
Yes, sure. Hello, everyone. So the first question is from Jukka Niiranen to Joanna from Sensar, and he is asking, what is the exact problem that you are solving for the cities? So can you clarify that?
Yes, thank you. Well, excellent question. Sorry it wasn't clear, but well, our solution basically addresses the need for up-to-date information on the state of all assets in a city, basically. And I feel like, yeah, as we mentioned already, like a lot of the solutions that have been presented today are addressing this kind of need. But like problems that the cities are facing is, for instance, yeah, like outdated information on the state of an asset. Radar provided a great example on a failure of a tunnel as well. So failure of infrastructures, things like this, differential settlement as well, that between houses and the pipeline that's basically connected to the house. So pipeline failures as well that are concerning problems. But also rainwater drainage is one of the big ones that, especially with the climate change as well that we are facing currently, that we have more rainfall. And if the drainage of rainwater is not going into the right direction, that leads to flooding. But with having this kind of like elevation profiles on up-to-date information on it, you are aware directly of like, where is my rainwater flowing? And is it flowing in the right direction? So these are the few. I can go on, but we'll have a discussion about it. So get in touch if you want to know more.
Perfect, thank you. And Ari, there's another question, I guess, by the same person.
Yes, indeed. This is for Denise from Neptune. And the question is, what is the current development phase of your solution?
Yeah, our prototype is currently undergoing real-world testing, operational testing. That is why the reason why Ricardo isn't here today. And we do our test in a controlled but realistic environment over existing water infrastructure. These are not lab simulation, but field tests, known leakage-prone sections. Sensar has already been applied to real-world cases. However, the integration between GNSS-R and Sensar, the data fusion layer is still under design and will be developed during this phase 1 of SPACE4Cities. Our aim is to build a unified and scalable processing chain of our prototype.
Oh, excellent. I think apart from another comment, there isn't anything else, Ari, from the audience on the chat?
No, and yeah. You still have a time to ask questions, and if you want to present them, like raise your hand.
Of course, I think so. Yeah. So what I wanted to do now is like whoever also in the audience would like to sort of ask some more questions to clarify or provide some feedback, please. Just raise your hand and you will get the floor. Okay, we've got Owen from Amsterdam. Owen.
Hi, is my audio working? Oh yeah. My first question to Denise is about GNSS-R data that you're collecting. Is that collected purely by satellites, by the GNSS satellites, or do you need any ground-based sensors as well?
No ground there, only satellite.
Okay, thank you. And Joanna, my other question to you is about your city detect module. It shows that it has a detection of developments in cities. So, but what can it specifically detect? Can it classify certain things, or?
It can basically detect the changes in infrastructure, since it's also based on Sensar time series. So with Sensar, we of course can measure, well, can or get observations on infrastructure, so anything that is hard, paved. So build new building sites, but we also tested it on basically new land detection. So if there's water that is flowing away, it can detect new land formation basically as well. So yeah, it's not yet fully the solution there and where it will go, but this is the idea for this phase, of course.
But
Okay,
changes in infrastructure again. I mean, it's not necessary that someone's painted a graffiti on the building, right? So
No. More like someone built a shed, or someone built a new house, or of course a new bridge, or there's road construction. So it can of course also detect like not like something is built already, but also like something is being built in that sense. So like changes basically in that sense. But also something related more to water. Yeah, that could also be an interesting one.
But would it only detect the change, or would it actually be able to classify what is actually happening?
For now, it only detects the change. To actually classify it, there is more development needed into the algorithm, but also like more input in sense of like, okay, not only INSA can be the input for this. But a great idea.
Yeah.
thank you, Boone. Anyone else from the audience who would like to ask another question? Okay, good. I have one more. Before we close the meeting, it was also related to the sort of water infrastructure case by Denise. I think so it sounds quite amazing what you could do. Obviously, leaks are a big sort of loss of revenue and of a sustainability issue for any sort of water infrastructure operator. Does your solution have any assumption on the depth? So can you do this on all all water distribution infrastructure, or can it be just pipes buried under a certain level of depth, for instance, or a certain size of leaks you're able to see only in? So what is sort of your constraint here?
Hi, good morning, everyone. I'm Enrico from Urban Lens team. I'm taking the floor to I want to let you know that water leaks. Obviously, we are talking about underground pipelines. So our aims is to see underground pipelines till 1.5 meter deep. But you have to know that sooner or later, a water leaks goes on the floor. So we are taking to catch the leaks before it goes on the ground, of course, and we use the phenomena of capillarity. Of course, a GNSSR system can go deeper as 1.5 meters. More or less in our studies, we can go deep about 30-40 centimeters down the concrete. But we use the capillarity phenomenon because the pipeline are posed in a sort of sandy place. So when the water occurs, it fills all the space before going into the ground. We already have experience with Sensar. More or less, the capacity is the same of the GNSSR systems. But the difference is that we have the data available all the days instead of L-band that we have more or less over 15 days.
Okay, thank you. Brilliant. Okay, that's it's quite a feature, but very good. Okay, good. Yes, so I think if there are no further questions, I would like to first of all thank all the speakers for joining in today and sharing their expertise and also time with us. So big applause to you guys. Thank you so much. And yes, also I would like to thank everyone else who was interested in this webinar to join in. I think I could see we were nearly 70 at some point during the session. So obviously we will share the recording as well afterwards. And obviously, we also will hope to share the slides. So if you feel there's something that shouldn't be included, then please feel free as well to send me a redacted version if this makes you more comfortable, right? So, but please, for the speakers, if you could sort of make the slides, if I can go with a PDF of the current if you want, or if you want to have a specific version, please send it to me this week. Okay, amazing again. Have a great rest of the afternoon and day, and yeah, and hopefully I will see some of you in the next webinar in an hour. Okay, take care.
Thank you so much.
Thank you all.
Bye.
Thank you.
Thank you. Bye.